Okay, I'm going to do a problem here on page 420, number 17. We have a word problem here. It says a walkway forms a diagonal of a square playground. The walkway is 24 meters long. To the nearest tenth of a meter, how long is the sides of the playground? So let's kind of draw this picture. We got a playground, but not only is there a playground, it's a square playground. All right? So I'm going to just draw something that looks pretty much like a square. Of course, 90 degrees, all sides are the same. There's a walkway that is 24 meters long, and the walkway, by the way, is the diagonal. So this being the diagonal, it is 24 meters. The question is now, how long is each side of this playground? How long is each side of this square? Well, that will be x. Now, because it's a square, they're both x's. And just focusing on this triangle, this is 24, this is x, this is x. And if it's a right triangle, you use Pythagorean theorem. So the setup would be x squared plus x squared is equal to 24 squared. Opposite the 90 degrees is the c squared. Let's add this 1 and 1. Do not say this is x to the fourth. That's if you were multiplying. If you've got one of these guys here, one of them here, and if I'm going to add them, now I got two of them. 24 times 24 is 576. Then divide by 2. X squared divided by 2 is 288. We're going to take the square root of 288. And the answer is square root of 288. 16.97, but they say rounded to the nearest tenth, so this would go up, and this would actually be 17 meters. So if this is 24, this is 17 and 17. That is problem number 17. Okay, now we're going to do problem number 21 through 26, but really just 21. It says classify the triangle as either a right triangle, acute triangle, or obtuse triangle. Well, you're going to have three side lengths. Obviously, triangles have three sides, and you want to use the Pythagorean theorem. If things are equal, then of course you know you have a right triangle. If the a squared, b squared is greater than, then you have an acute. Again, this is greater than. If the a squared and b squared is less than, you have obtuse, meaning you have a really big c side, which makes an obtuse angle here. Okay, so when you have this, you're just going to plug it into this formula and then decide what you have. When you're doing this as well, the biggest number always has to be c. So this one, the way they order it, looks like the biggest number here, 6, is going to be c. But if they put 6 in the front, don't treat this like this is a, b, c. You've got to always have the biggest number being c, no matter where they put it in the order. Okay, so this is going to be simply 4 squared plus 5 squared, and I'm not going to put an equal sign there. I'm just going to say question mark, question mark. 4 times 4, 16, 25, 36, 41, 36. 41 is clearly greater than 36, which means you have an acute triangle. Okay, no one side is particularly huge, so you have an acute triangle. Okay, I'm going to do number 27 here. We're going to figure out this x value here. We've got some information. 26, 26 looks like an isosceles triangle, the big guy here. 48 here. In order to do this, we are going to be using right triangles and simply doing a squared, b squared, c squared. I have over here a picture which basically we have a right triangle on the left and a right triangle on the right. We have obviously reflexive property down the middle. Those legs are equal. 26 and 26, we have congruent sides, and actually it's an hypotenuse, and we have right angles. So these two triangles are equal because of hypotenuse leg. And when side lengths are equal, of course that means all the corresponding parts inside congruent triangles are equal. So this side here is the same as this side here. So if it's all the way across 48, then halfway across would be 24 and 24. So then all you need to focus in on is this 24, 26 x triangle. We're going to do our a squared plus b squared is equal to c squared. Obviously you want to make sure the correct number for C is opposite than 90 degrees. I'm just using my calculator here. X squared plus 576. 26 squared is 676. We're going to minus this over x squared is equal to 100. Square root of 100 is 10. So the answer is 10. Finally, we're going to do problems 50 and 51 here. And they give you this bizarre looking figure here. And I put it on graph paper because you're going to kind of need to count. They want to know the perimeter of this figure. And perimeter, as you should know, is adding up all the sides on the outside. So some of these are easy to count because obviously on graph paper you can count 1 space, 2 spaces up and down. You can count 1 space, 2 space, 3 spaces left to right. The problem will occur if you got things at a diagonal, like there's no tick marks going diagonally. So how do you deal with that? Well, we'll talk about that in a second. Let's deal with the simple ones that are going up and down and left to right. From here to here, this is 2 spaces. Then this is 1 space going to the right. This is 1 space up, 1 space to the right, 1 space up, 1 space to the right. So at this point we have a 2 plus 1 plus 1 plus 1 plus 1 plus 1. And then the hardest one. How do you count something at a diagonal like that yellow line? Well, we have been in the section about right triangles. So what you're going to do is that yellow line and these two sides will create a yellow right triangle. Now you can count left to right here. 1 space, 2 space, 3 spaces. Of course, this is a right angle here. 1 space, 2 space, 3 space, 4 spaces. So this is the C, and I will go a squared plus b squared is equal to c squared. To save us time, the answer is 5. So this side length here is 5. So now going back, 2 plus 1 plus 1 plus 1 plus 1 plus 1 plus 5. And this answer should be perimeter is 12. Okay. Same idea with 51. When you do 51, you're going to have 2 right triangles. There's this one here. 1, 2 spaces. 1, 2, 3, 4 spaces. So that green right triangle, do a squared b squared is equal to c squared. And then we have another one here. This is a 3 by 4 by C right triangle, and then figure out the perimeter.